In this lecture, we will continue our discussion on properties of closure of a set. We have already discussed property number 1. Here we will going to discuss property number 2. Properties on closure number 2. Closure of A is the smallest closed superset of A. Closed superset of A. Superset of A. That is closure of any set is the smallest closed superset of A. Proof. First, we will show A closure is closed. Then we will show that A closure is the smallest closed subset of closed superset of A. So right, first let A closure. First we shall show that. A closure is closed. It is sufficient to show complement of A closure is open. To show this open, if this is empty, complement of closure of A is empty, then we have nothing to prove. It is trivially open. Okay. Next, so let complement of A closure is not empty. Then for all x belongs to complement of A closure, x does not belong to A closure. That means x does not belong to A union B of A. That is set of limit point of A. This implies x does not belong to set of limit point of A. And by definition of the limit point, open sphere center at this point for some real number r greater than 0 is not open. Then by definition of limit point, we will get some open sphere SRX for some r greater than 0 such that SRX intersection A is empty. This intersection is empty. That is, it does not satisfy this definition of limit point. Okay, as x is not limit point, so this definition is not satisfied. So this intersection is empty. Now, SRX being open set, we know every open sphere is an open set. SRX is open set. Since SRX is open set for all y belongs to SRX, there exists open sphere center at this for some r1 greater than 0 for some real r1 greater than 0 such that as r1y intersection SR1y is contained in SRX. Since SRX is an open sphere, so each point belongs to this SRX. We will get some open sphere contained in that set. Okay. Now this SRX intersection A is empty and SR1y is a subset of SRX. So this intersection SR1y intersection A is again empty. This implies Y is not a limit point of A. Okay, that is Y does not belong to D of A. Y does not belong to D of A. That is Y does not belong to closure of A. Where Y belongs? If Y does not belong to closure of A, Y belongs to its complement. Complement. Initially, I have considered Y belongs here. I have got Y belongs here. Therefore, this open sphere SRX is a subset of Y, subset of A closure complement. We have considered for all S belongs to A closure complement. We can draw an open sphere that is contained in this set. That means our set is an open set. It's open. That means when complement is open, that means the set is closed set. Okay, closed set. We have shown that A closure is closed. Next, we are going to show that A closure is the smallest closed superset of A. For that, we consider any closed superset of A. That is, we consider F to be any closed superset of A. We will show that this A closure is contained in this arbitrary closed superset of A. F F arbitrary closed superset of A. Then we are done. So right. Let F be closed superset of A. Okay. Then A F contains A. So take closer both sides. Take closer both sides. That means here F is a closed superset of A. When F is closed, then F is equal to F closer. Since F is closed, so given only if F is equal to F closer. Okay. This implies F contain closure of A. Put this equation 1 and this equation 2. From 1 and 2, we can conclude that from 1 and 2, we have that is A closure is closed and F any closed superset of A contain A closure. Therefore, from 1 and 2, we have A closure is the smallest closed superset of A. The smallest closed superset of A. Superset of A. Hence the proof. Hence the proof. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.